Improvement in everyday life and culture up to the 20th century has given rise to mass production and mass consumption. This has resulted in the expanded use of fossil resources. On one hand, consideration for cost and consciousness towards the environment were not as high as it is today. But in recent years, the way of thinking towards the environment, such as environmental burden and resource issues, has changed. The creation of the sustainable society without using fossil fuel has become a vital need. The future ushered in by cellulose nanofiber, possibilities of biomass materials in creating the sustainable social infrastructure. Cellulose nanofiber is one of the elements that constitute all plants and is an extremely fine nanofiber. Its main characteristics are high strength, lightweight, and very low value of thermal expansion. Since plants are organisms that accumulate CO2 in the atmospheric CO2 does not increase no matter how you process them. In other words, cellulose nanofiber is a carbon-neutral biomass material. Because of this, cellulose nanofiber has come to be known as a new environmentally adaptable material and is highly evaluated as a post-carbon fiber. In the last 15 years, cellulose nanofiber has dramatically gained attention as a material of the future, and more than 2,000 studies on it have been conducted in one form or another all over the world. In 2011, demonstration plants were constructed in Finland, Canada, and Sweden, among other places, and research has also dramatically flourished in the US and China. And there are two prominent Japanese experts who created a revolution in this research field. Dr. Hiroyuki Yano, Doctor of Agriculture, Professor of the Division of Creative Research and Development of Humanosphere, Research Institute for Sustainable Humanosphere at Kyoto University. Initially, he worked on materials physics mainly for musical instruments. In 1994, he declared, "I would like to produce the strongest wood in the world," and began to take on the challenge of becoming an expert in nanocellulose. He was a pioneer of nanocellulose in Japan. Dr. Yano says, plants are already doing 99.9% of the process of producing nanomaterial, and the remaining 0.1% is for human beings to think hard about. In 2001, he discovered that if pulp made into nanofibril is laid out as a sheet-layered structure, fracture strain increases and a high-strength material can be created that is as strong as steel. The world's highest-strength CNF material was thus developed. In 2005, a cross-sectoral vertical cooperation research system was established by him as an area revitalization consortium project. Research was launched based on the development theme of manufacture of biomass nanofiber and development of plant-based nanocomposite. In 2012, pulp nanofibrillation and homogeneous dispersion into resin were simultaneously accomplished. In 2016, using this technology, the lightweight, high-strength, and high-performance nanofiber with excellent thermal resistance and compatibility to resin, and a first-in-the-world, efficient, and continuous manufacturing process to produce resin composite material were developed. With this method, the necessary time and cost for manufacturing cellulose nanofiber reinforced material has been drastically reduced. Cellulose nanofiber was a completely new raw material for the industrial world then. We will develop this material as one of the structural materials for automobile, motorcycle, and aircraft construction. This will lead to lightening of weight, dramatic improvement of fuel consumption, and drastic reduction of CO2 emission. Dr. Akira Isogai, Doctor of Agriculture, Professor of the Department of Biomaterial Sciences, Graduate School of Agriculture and Life Sciences at the University of Tokyo. Taking a hint from a publication of the Netherlands group, he started the work applying the chemical approach to nanocellulose. In 2006, he developed a single nanofiber using tempo catalytic oxidation effect and published the results. Whereas its fabrication process applying high temperature and high pressure used to entail huge cost and time, a catalytic reaction was discovered in which, using tempo, wood cellulose is selectively oxidized and separated evenly into 3 nanometer wide nanocellulose by simply mixing it using a home blender under normal temperature. Dr. Yano also was surprised by its convenience. This discovery has revitalized research institutes in different environments around the world, resulting in huge developments. Because of this, in 2015, he was conferred the Marcus Wallenberg Prize, also known as the Forest Nobel Prize, which is a prestigious award with Swedish origins. Moreover, he received an honorary doctorate degree of Science and Technology from Aalto University, Finland, in 2016 for his outstanding achievements of nanocellulose research. From his research, various applications have been made since 2015. For example, super deodorants for paper diapers and ballpoint pens with improved smoothness of ink with skip-free writing, applying the metal ion absorptivity in a wide surface area of nano-raw material among the many properties of cellulose nanofiber. Nanocellulose Forum. This forum was launched in 2014, receiving great influence from the founding chairman, Dr. Yano. Presently, Dr. Isogai is the vice chairman. The two express the same opinion that network creation is extremely important for development and practical applications of nanocelluloses. The forum received total cooperation from nearly 200 companies, including automakers, as well as various government agencies, including the Ministry of Economy, Trade and Industry, which recognized this as a huge front for Japan revitalization strategy. They also established a cross-sectional great collaborative network regardless of industry, government, and academia in different fields that includes the local governments and the research institutes of Kyoto University and the University of Tokyo. It aims for cellulose nanofiber basic research and application and the pioneering of All Japan framework. Cellulose nanofiber is being developed for use in such diverse areas as transportation, electronic devices, energy devices, the medical sector and the environmental sector, and its application has partially begun. This will become a major pillar of society in the future. The roadmap has been created and cellulose nanofiber research has moved on to a new stage. For it to be a material that everyone can use, it is necessary to enhance the price competitiveness. We should not exploit resources, but generate products by growing closer to nature. The trend towards a shift to sustainable material will continue. Cellulose nanofiber is presently the most advanced material, and the possibility of a huge paradigm shift replacing petroleum has finally come. In the future, there is a possibility that cellulose nanofiber will be a revolutionary material that will create the sustainable and environmentally friendly society. I expect that the development of cellulose nanofiber will lead us to creating the sustainable society that we human beings have long aspired to bring about. When we look back at history 100 years from now, when such a society is finally realized, it will be most delightful if the realization of this society started from our research on cellulose nanofiber material. In the future, cellulose nanofiber material would play a revolutionary role in creating a sustainable society.